For over a decade, the Cassini-Huygens mission, a collaboration between NASA, the European Space Agency, and the Italian Space Agency, redefined our understanding of Saturn, its rings, and its moons. This ambitious endeavor, launched in 1997, ended in 2017 with a dramatic plunge into Saturn's atmosphere. A grand finale to protect its pristine moons. So buckle up, space fans. Join me as we count down the top 7 most profound discoveries made by Cassini-Huygens before its grand finale. Picture this. January 14th, 2005. The world watched in anticipation as a tiny probe prepared to make history, millions of kilometers from Earth. This was the day the Huygens probe would attempt something never before achieved, landing on the mysterious surface of Titan, Saturn's largest moon. After a 7-year journey clinging to the side of the Cassini spacecraft, Huygens finally detached, embarking on its own perilous adventure. The separation was a tense moment, the culmination of years of planning and engineering. Its mission was audacious, to pierce the thick orange haze of Titan's atmosphere and touch down on a world unlike any other in our solar system. Titan, Saturn's largest moon, is a place shrouded in mystery, its surface hidden beneath dense clouds of organic smog. Larger than the planet Mercury, Titan was an enigma. For decades, scientists could only guess what lay beneath its impenetrable atmosphere. Was it a frozen wasteland or something more dynamic? As Huygens plunged through Titan's thick atmosphere, it became the first probe to directly sample this alien world. It measured the composition of the air, the speed of the winds, and the temperature gradients, sending back a flood of data as it fell. After a dramatic 2.5-hour descent, Huygens touched down safely. It was the first ever landing on a moon in the outer solar system, a feat that expanded the boundaries of human exploration. The images Huygens sent back were nothing short of breathtaking. They revealed a landscape sculpted not by water but by rivers, lakes, and seas of liquid methane and ethane. For the first time, humanity glimpsed the surface of this distant world. Imagine standing on Titan, watching methane rain fall from the sky, carving canyons and filling vast, rippling seas. The processes shaping Titan's surface echoed those on Earth, but with entirely different chemistry. Titan challenged our very definition of habitability. Its surface was cold and alien, yet strangely familiar in its geology and weather patterns. The data from Huygens, combined with Cassini's sweeping flybys, revealed that Titan is rich in complex organic molecules, the essential building blocks of life as we know it. This discovery ignited new questions about the potential for life elsewhere in the universe. Suddenly, this hazy, distant moon became a natural laboratory for understanding the chemistry that might have preceded life on Earth. Scientists around the world pored over the data, searching for clues to our own origins. The Huygens landing was a testament to human ingenuity, perseverance, and curiosity. It proved that with vision and determination, we could reach out and touch the unknown. It was a giant leap for humankind, taking us to a world we could only dream of before, a world that now feels just a little bit closer. Titan opened our eyes to the possibility of life as we don't know it, and to the wonders that await us in the far reaches of our solar system. And it all started with one daring descent, an extraordinary journey that forever changed our understanding of what's possible. Now let's talk about Enceladus, another of Saturn's moons that truly stole the show during the Cassini mission. While Saturn has many fascinating moons, Enceladus stands out for reasons that have captivated scientists and space enthusiasts alike. This tiny, icy world, just about 500 kilometers across, turned out to be one of the most exciting discoveries of the entire mission. Why? Because it's actively spitting water into space, creating spectacular plumes that shoot hundreds of kilometers above its surface. Cassini discovered enormous plumes of water vapor erupting from Enceladus's south pole, like geysers on a cosmic scale. These jets are so powerful that they actually contribute material to Saturn's E-ring, forming a shimmering halo around the planet. These plumes originate from a vast, global ocean hidden beneath the moon's thick, icy shell. Imagine an entire ocean, locked away under kilometers of ice, kept liquid by heat from within. Cassini flew directly through these plumes, sampling their composition. What it found was astonishing. Organic molecules, salts, and tiny grains of silica, all pointing to the presence of hydrothermal vents on the ocean floor, similar to those found on Earth. On Earth, hydrothermal vents deep in the ocean support vibrant ecosystems, teeming with life, even in total darkness and without sunlight. These vents provide energy and nutrients, creating oases of life in the most unlikely places. Finding evidence of similar vents on Enceladus was a jackpot in the search for extraterrestrial life. It means that even far from the sun, moons like Enceladus could have the right ingredients and energy sources to support living organisms. Its hidden ocean, warmed by tidal forces from Saturn's immense gravity, could harbor the conditions necessary for life to thrive: liquid water, heat, and organic chemistry all in one place. Enceladus became a game-changer, proving that the ingredients for life might be far more common in our solar system than we ever imagined. It opened our eyes to the possibility that life could exist in places we once thought impossible. So never judge a moon by its icy shell. Sometimes the most extraordinary secrets are hidden just beneath the surface. We've landed on Titan, explored its methane seas. But Cassini wasn't done with this intriguing moon. Using radar, Cassini peered through Titan's thick atmosphere to reveal a world both familiar and alien. Vast dune fields stretch across the landscape, sculpted by winds, except these dunes are made of organic molecules. Rivers and lakes of liquid methane meander across the surface, mapped in exquisite detail. Titan's methane cycle mimics Earth's water cycle, but with a completely different chemistry. Scientists believe Titan's atmosphere may resemble early Earth's before life arose. Studying Titan is like taking a trip back in time to a primordial Earth. Titan is a cosmic laboratory, where we can study the chemistry that may have paved the way for life. Sometimes the most alien worlds hold clues to our own origins. Titan reminds us the universe is full of surprises. Saturn's rings have captivated astronomers for centuries, their shimmering beauty inspiring wonder and curiosity. But it was the Cassini spacecraft that truly unveiled the astonishing complexity hidden within these iconic bands of ice and rock. Cassini revealed that the rings are not solid but instead a chaotic ballet of countless icy particles, ranging in size from tiny grains of dust to massive boulders, each following its own unique orbit around Saturn. Within this cosmic dance, intricate patterns emerge: waves, braids, and even mysterious spokes, each feature sculpted by the invisible hands of gravity, as Saturn and its many moons tug and pull on the ring particles. Imagine a giant cosmic vinyl record, its grooves carved not by a needle but by tiny moonlets embedded within the rings. These moonlets act as celestial sculptors, shaping the structure of the rings as they orbit. The grooves left behind by these moonlets create waves that ripple outward through the rings, much like the gentle ripples that spread across a pond when a stone is tossed in, revealing the dynamic nature of this system. Among the most enigmatic features are the spokes, ghostly transient streaks that appear and vanish. Scientists believe these are likely caused by electrostatic forces which lift tiny ice particles above the ring plane, creating fleeting shadows and patterns. Cassini's long-term observations showed that the rings are far from static. They are constantly changing, shaped by the interplay of gravity, electromagnetism, and the relentless passage of time. The rings are a dynamic, ever-evolving system, offering scientists a living laboratory to study the forces that govern planetary formation and evolution. Through Cassini's eyes, we glimpse not only the beauty of Saturn's rings, but also the ancient processes that shaped our own solar system billions of years ago, reminding us that the universe is a place of both order and chaos, forever in motion. Saturn was already known for its impressive moons, but Cassini discovered 7 new ones orbiting the giant. Some are tiny, barely a few kilometers across, more like giant space boulders than worlds. But these little moons play a big role in shaping Saturn's rings. Take Daphnis, for example. Just 8 kilometers across, it orbits within the Keeler Gap, creating waves that ripple out on either side. Even the smallest objects can have a profound effect on their surroundings. Pan, another small moon, carves out its own path within the Encke Gap, clearing a path through the ring particles. These discoveries provided valuable insights into the dynamics of ring systems and gravitational interactions. Cassini showed us that in space, size isn't everything. Even the tiniest moons can leave a big mark. Saturn may seem serene from afar, but Cassini revealed its wild side. The spacecraft witnessed massive storms, including the Great White Spot, a colossal storm that erupts every 30 Earth years. Imagine a storm so large it could engulf Earth with winds over 1,000 kilometers per hour. The most bizarre feature? The hexagon, a 6-sided jet stream encircling Saturn's north pole, still a mystery. Cassini also studied Saturn's magnetic field, almost perfectly aligned with its axis, creating a twisted magnetosphere. Cassini's instruments mapped this magnetosphere, revealing its complex structure and interactions with the solar wind. Saturn's wild weather and magnetic field gave scientists a wealth of data to unravel the mysteries of gas giants. Cassini wasn't just a mission, it was a testament to human ingenuity and our drive to explore. For 13 years Cassini orbited Saturn, sending back data that revolutionized our understanding of the planet and its moons. 294 orbits, 162 flybys, and a journey of over 4.9 billion miles. Cassini was the first spacecraft to orbit Saturn, sample its atmosphere, and send a probe to a moon in the outer solar system. These achievements expanded our reach into the cosmos and inspired generations to come. Cassini's legacy lives on, inspiring future missions like Dragonfly to Titan and proposed explorers to Enceladus. The solar system is full of wonders, and Cassini's legacy will continue to inspire us to reach for the stars. Cassini-Huygens wasn't just a mission, it was a saga, a testament to human curiosity and our relentless pursuit of knowledge. Over 20 years, it beamed back over 450,000 images and fueled nearly 4,000 scientific papers. Cassini-Huygens ignited our imaginations, revealing a Saturnian system more diverse and dynamic than we ever imagined. These discoveries have fueled a new generation of missions to explore the possibilities of life beyond Earth. What do you think was Cassini's most important discovery? Let us know in the comments and don't forget to subscribe for more space stories.